So welcome to the learning series where we cover a number of different topics. This part we're reviewing the new exam basic questions that came out July 15th. So we're on section 7, propagation. So we'll do two sections today. So sections A and section B. So this is just how the slides are presented. The exam question is on the left. On the right is a summary of the key material, and anything new is in bold. And then something also new for the exam is that you now have a study aid, and you also have a reference material that will be provided by your examiner for the exam. And these are also online. So the study aid is, you can't take that into the exam, but the reference material is available on the exam. So this is an example of a study aid where you're given the formulas and an explanation on the formulas. You're also given the various diagrams with everything labeled. And the reference material for the exam is the same, but nothing is explained. So you have your formulas, but they're not explained, and you have your diagrams, but nothing is labeled. So we're on section 7, propagation. And in the first part, we're covering line of sight, ground waves, ionosphere, hops and skips, and absorption and fading. So what is the type of wave propagation usually occurs between two nearby VHF transceivers? So for VHF, a lot of it is line of sight. So B is the correct answer. Here is a new question. What does near vertical incidence skywave NVIS propagation enable? So this is where you're sending your signal straight up and you're having it come down at various angles. So it's typically provides medium range HF communication, especially in difficult terrain. So A is the correct answer. When a signal is returned to Earth by the ionosphere, what is it called? So in this case, with the ionosphere being involved, it's a skywave. So it's called C, skywave propagation. Here is another new question. On VHF and higher frequencies, why does the radio horizon extend beyond the visible horizon? And that is due to the normal refraction of the troposphere. So that D is the correct answer. What type of wave is commonly known as sky wave? So sky wave is related to the ionosphere, so B, ionospheric wave. What portion of a radio signal is directly affected by the surface of the Earth? So that would be what's closest to the Earth would be the ground wave. So the ground wave is the correct answer. What makes radio communication out of 200 kilometers possible at lower HF frequencies during the daytime? So that would be A, the ground wave. It provides close distance communication. Considering the bands from 160 meters to 6 meters, which band offers the greatest ground wave propagation distance? And this would be the lowest frequency or the highest band. So D would be the correct answer, 160 meters. What type of radio wave follows the path from the transmitter to the ionosphere and back to the Earth? So because the ionosphere is involved, that would be a sky wave again. So C is the correct answer. Reception of high frequency HF radio waves beyond 4,000 kilometers is generally made possible by, and that is due to the ionospheric wave or the sky wave. So D is the correct answer. Now we get into questions about the ionosphere. So what causes the ionosphere to form? And A is the correct answer. Solar radiation ionizing the outer atmosphere. So A is the correct answer. What type of solar radiation is most responsible for ionization in the outer atmosphere? And that would be ultraviolet radiation. So C is the correct answer. And now we're looking at the different layers of the ionosphere. So what ionospheric region is closest to the Earth? So that would be the D region. So B is the correct answer. What region of the ionosphere is the least useful for long distance radio wave propagation? So that would be the one that's closest to the Earth. That would be the D region. The D region absorbs a lot of the RF signal. Which region of the ionosphere separates into two subregions in the daytime? So that would be the F region. So it's two regions in the daytime and one region at nighttime. Which region of the ionosphere separates into two subregions in the daytime? So again, the same question, it would be the F region A. When is the ionosphere most ionized? And that would be C, midday. When is the ionization at the minimum in the ionosphere? And that would be D, shortly before dawn. Why is the F2 region mainly responsible for long distance radio wave propagation? So, and the answer is A, because it's the highest ionospheric region. So what happens is the signal bounces up, hits the ionosphere, and then bounces back down to Earth. And the higher you go, the further the distance it can travel. So F2 is the highest region. What is the main reason that the 160-meter and the 80-meter bands tend to be useful only for short distance communication during the daylight hours? And that's because of the D region absorption. So B is the correct answer. Here's another question. During the day, what two subregions appear in the ionosphere? And again, that would be the F1 and the F2 region. So B is the correct answer. What is the position of the E region in the ionosphere? So the E region is below the F region. So the way it works, if you have the Earth, you have your D region, you have your E region, and then you have your F region, and your F region breaks into F1 and F2 during the day. Now we get into hops and skips. So what term describes an area that is too distant for reception of ground waves, but too close for reception by ionospheric waves? And that would be known as a skip zone. So you wouldn't get any communication there because you're too far for ground wave and too close for ionospheric waves. So that's a skip zone. What is the maximum distance along the Earth's surface that is normally covered by one hop using the F2 region? So that would be 4,000 kilometers. So B is the correct region. Answer. What is the maximum distance along the Earth's surface that normally is covered in one hop using the E region? So if the hop is at the E region, that the answer would be D. So 2,000 kilometers. And because E is lower than F, it has to be less in distance. So 2,000 is the correct answer. What is a skip zone? So a skip zone is a zone between the end of a ground wave and the point where the first ionospheric reflected wave returns to the Earth. So A is the correct answer. The distance to Europe from your location is approximately 5,000 kilometers. What type of high frequency HF propagation is most likely to work? So in this case, you would be having multi-hop as the method of propagation. Here's a new question. Assuming constant ionospheric region height, what does a higher radiation angle how does a higher radiation angle affect skip distance? So it decreases due to the geometry of the signal path. So C is the correct answer. So here you're looking at the takeoff angle of the antenna, and the takeoff angle is different. So if the takeoff angle decreases, um, it affects the skip distance by decreasing it. Another new question. On the double hop path involving the surface of the Earth as a middle point, what phenomenon returns the radio wave to the ionosphere? So in this case, it's D. The answer is reflection. Skip distance is so we have the skip zone, now we have the skip distance, and the skip distance is the minimum distance required by a signal after one reflection by the ionosphere. Skip is a term associated with signals from the ionosphere. What causes the skip? So here the correct answer is refraction by the ionosphere. The skip distance of a sky wave will be greatest when again, this all has to do with the angle of the antenna and the height. So B is the correct answer. Angle between the ground and the emitted radiation is the smallest. So B is the correct answer. For greatest distance, you want an antenna that gives you a low takeoff angle. How does an increase in height of the refracting region affect skip distance? So the skip distance increases due to the geometry of the signal path. So C is the correct answer. Now we get into absorption and fading. What effect does the D region of the ionosphere have on low frequency HF waves in the daytime? So what the D region does, it mainly absorbs the radio waves. So C is the correct answer. And then why can you not hear distance 160-meter and AM broadcast stations during the daytime hours? And that's because of the ionization in the D region. So C is the correct answer. The ionization in the D region causes absorption of the radio signal. So you want enough ionization to allow propagation to happen, but you don't want too much ionization that prevents the propagation. A radio transmission may follow two or more different paths during propagation, and this may result in a phase difference at the receiver. What is the effect at the receiver? So with these skips and hops and skywaves and other forms of propagation, they may follow different paths, but eventually get to your receiver at nearly the same time. But they will be out of phase with each other, so that's known as fading. Here's a new question. when using a 2-meter handheld transceiver in an urban setting, you notice that moving less than 1 meter can severely attenuate your received signal. What is the likely cause? And so this is again related to different paths. So A is the correct answer. Signals arriving on different paths cancel one another out. That's why it's best to move your handheld around if they say if they can't hear you or if you're unclear. A transmitted radio signal reaches a receiver by both 1-hop and 2-hop skip paths. How can small changes in the ionosphere cause? What can small changes in the ionosphere cause? So D would be a variation in signal strengths. What can be done to continue HF communications during a sudden ionospheric disturbance, an SID? So what you would do here is try a different frequency, and you would try a higher frequency band and see if it makes any difference. On the VHF and UHF bands, the polarization of the receiving antenna in relation to the transmitting antenna is very important. Yet, on HF bands, it is relatively unimportant. Why is this so? And that's because as the signal transfer goes through the ionosphere, it changes polarization all the time. So C is the correct answer. The reaction in the ionosphere changes the wave's polarization. What causes selective fading? So that, again, that's related to phase differences. So C is the correct answer. Phase differences between the radio wave components of the same transmission as experienced at the receiving station.
Okay, sorry, Roy, can you go back one?
Yes.
Previous slide.
Yeah. This one?
Yeah.
Or this
746. Oh, no, 746. What can be done to continue HF communications during a sudden ionospheric disturbance, SID? B, try a higher frequency band. Why? Why not lower?
You could try a lower one too. In this case, higher may eliminate some of the ionospheric, may change the skip distance, and it may work slightly better. But if you go too high in frequency, it doesn't work either.
Well, what's you,
I
you know
would-
what's in you know
Well, I
what's
mean,
interesting
the
about
thing
this
is,
question?
the thing is, you want to change frequency, and when you go through the answers, the only one that talks about frequency is B.
Yeah,
So,
that's what I wanted to say. Thank you. That's
yeah,
that's what I wanted to hear. Thank
could
you.
be higher or lower.
Yes, I just want to make sure that
It's
well,
not
you
the
were
best.
going through them pretty fast and I was getting like sleepy. Okay, thanks.
It's not the best question.
No, but it is by process of elimination that you get
Yes.
that answer. Yeah,
Yeah.
thank you.
Why does the bandwidth of a transmitted signal affect selective fading? So, if your signal is wider that you're trying to send through, it's more sensitive to possible fading. So C is the correct answer. It's more pronounced at a wide bandwidth because it's a larger signal that you're transmitting over the air. What effect do refraction, reflection, and Faraday rotation have on a radio wave? So all of these happen in the ionosphere. Faraday rotation has more to do when you're hitting a moving object like a satellite. So it all changes the polarization of the signal. So D is the correct answer. If a radio transmission follows 2 or more different paths during propagation, the received signal may decrease due to fading. what other type of degradation can occur? So again, you can have something that will affect the phase of the signal, so you can also get phase shift distortion. So A is the correct answer. So we'll finish this section. So let me just stop the recording and then we'll go on to the second section.